Hi guys, welcome to the math lesson today on Tuesday, April 21st. We got an entrance task where you're going to find the volume of a rectangular prism here on number 1 and a triangular prism on number 2. So you had a bunch of problems like this. This is the easiest variety of volume problem that you had to try last night on page 15. When you have a rectangular prism, remember the volume is just simply the length times the width times the height. When you have the volume of a triangular prism, right, or anything that's not just a rectangular prism, you really want to think of it as the area of the base, right, and then stacking that up for the whole height of that. So what you're really going to want to do here is finding the area of this front triangle. Okay, so it's a two-dimensional area. Remember, the area of a triangle, the separate problem you should be doing here, the area of just a triangle, not a triangular prism, but area of just that front, that side triangle that's in orange right there, is the base times the height of that triangle divided by 2. That'll give you the area of this front triangle right in here, okay? If you can take that area and stack it up the whole distance until you feel like, imagine filling this whole prism up with these triangular shaped pieces of paper till you got to this back triangle here. That would be for a whole length of 9 centimeters. That would be the way to find the area of this triangular prism. If you check page 14, the notes from yesterday, you have an example on one like this too. So pause the video, see if you can get the volume for number 1, which hopefully seems pretty easy, and then hopefully you can get number 2 as well, but I will go over the answers to that in just a second after you pause it and try it. Alright, so here is the answer for number 1. The volume is going to be just length times width times height, and it's just going to be the dimensions that I have. Depending on how you want to look at this thing, you could have it as 12 times 5 times 9, right? Wait, I thought the width was 9 and the height was 5. That's understandable. That's correct. All right, you can put this thing any way you want. You could imagine setting this box, because it looks like a box, setting that box any which way you can, setting it on the 12 by 9 side, or turning it and setting it on the 12 by 5 side, whatever you want. But then, so now we just got to be able to do the math here. And when you multiply those all together, you end up getting an answer of the volume equals 540. You could say centimeters cubed, or you could spell it out as cubic centimeters. And that would be easier probably to write when you do the assignment today is on Google Docs, to just have your answer in cubic centimeters, probably just to write it like that. Okay? Now, before I go over the answer to number 2, I just want to show you that this is really the same. You can use the same logic on number 1 as you can number 2. In fact, if I highlight this front rectangle in orange, okay, you can see that that's a 12 by 5 rectangle. Okay, that's like a sheet of paper right there. The area of that sheet of paper on the front, okay, that front rectangle right there would be 60 centimeters squared. Well, if you can imagine stacking these like envelopes, kind of pieces of paper, if you could stack the 12 by 5 rectangles here, the whole 9 centimeters, alright, so you take the area of that front 60 and multiply it by the 9 centimeters. I mean, that's really what you have right here in this problem. You have 12 times 5 is 60 times 9, the whole distance till you get to that other back rectangle, back of the prism, that's the same. So it's the area of the base, if I consider this 12 by 5 side of the base, times the height of stacking those pieces of paper the whole distance. Okay, it's the same thing here. If I took the area of this triangle, okay, which I'll continue to do the math right here, the area of that front triangle is, the base of the triangle is 6 times the height of the triangle is 8 divided by 2. That's 48 divided by 2. The area of the front triangle is 24. Okay, that's the area of the triangle. So when I try to find the volume here, the volume of the whole thing is going to be big B, the area of the base that we just found, the area of the triangle, times the height, which is the distance, the height of the prism. I know that it's not standing on its end, but it's that same 9 where If I stacked the triangle all the way up till it got to the back triangle, I'd have to stack it for 9 centimeters. Just like here on number 1, if I have to stack that rectangular piece of paper all the way till it got to this back rectangle back here, it would have to do it for 9 centimeters. So it's that same, just like the problem we just did over here, the area of that front side in orange we just found is 24 times the height of my prism. The area, but the distance between the two bases is 9. So hopefully you can see the similarities between number 1 and number 2. And I made the height 9 for both of them so that hopefully it'd be a little bit easier to see how that works. So now we just do the 24 times 9, and we get an answer of 216 cubic centimeters, or centimeters cubed, however you want to write it. Okay, so there's another example, and the 3 problems you're trying for tonight are going to be just like number 2 here. So that's a really good example to look at, along with the example from your notes yesterday on page 14. All right, let's take a look real quick at the page 15 answers. Hopefully we're really easy. Since they were all rectangular prisms, these are probably your favorite. All you had to do was length times width times height for all of them. So you can see I wrote them out: 6 times 8 times 3, 5 times 10 times 2, 15 times 7 times 4. It's just the dimensions multiplied. So I'll give you a second to look at those answers. You can certainly pause it if I'm going too fast, so you can check to see how you did on all those. And your answer for the last one, number 10, would be the 20 times 10 times 5, and that turns out to be 1,000 cubic meters, or meters cubed. Okay, so hopefully you did pretty good on page 15. Again, you're only going to try on page 16 just 1, 2, and 3, and I'm going to give you an assignment that you can turn in so you can share your answers to see how you did on that. I will post the answers on how to do that on tomorrow's video, or maybe it'll be 2 days even, because tomorrow we'll go over pyramids, so maybe I'll give you a couple days to try that 1, 2, and 3 in case you got something going on. Busy right now. All right, well, you guys have an excellent rest of your day, and I will check in with you guys soon. All right, bye.